Hi, today we talk about scalar and vector physical quantities. What's the difference between vector physical quantity and a scalar physical quantity? Well, the scalar physical quantity needs only numerical value and the right measuring unit to be described. Number and measuring unit. While in the case of the vector physical quantity, of course I need a numerical value and of course I need the right measuring unit, but also I need a direction to describe this physical quantity. Now let's see some examples of the scalar physical quantity. We have the speed, we have temperature, we have area, time, volume, mass, distance. All these quantities do not need direction to be defined. And for the examples of the vector physical quantities, we have displacement, electric field, weight, velocity, acceleration, force. All these physical quantities need direction to be described or to be defined. To add or subtract mass of two different objects, all you need is the mass numerical value for each object. To add or subtract force done on two different objects, what you need is the force numerical value done on the object and the direction. Yes, in the case of the vector physical quantity, you can add direction and subtract direction. And this is for another video. Well, now let's discuss another topic that's also related to scalar and vector physical quantities. Now let's see. We have something that's called distance and something that's called displacement. These definitions or these concepts, are they the same or are they different? So let's see this. We have this little puppy running in the garden. So this puppy is covering 7 meters or running for 7 meters to the west. Then, for no other reason than being happy, he decided to cover 4 meters to the south. Then he started to chase a butterfly, so he moved for 7 meters to the east. And the question is, how far did this dog move? There could be two answers to this question. One answer is, if I want how far this dog moved, all I need to do is to add the distances or the length he covered. So he ran for 7 meters, then he ran for 4 meters, then he ran again for 7 meters. This dog moved 18 meters. The total length covered by the object, the dog in this case, regardless of any direction, west or east or south, this is called distance. So distance is the total length covered by the object, and I do not need any direction to describe this physical quantity. All I need is numerical value and a measuring unit, the right measuring unit. Now let's see about the displacement. Again, we need to know how far did this dog move. Some people would say that all I need to do to know how far the dog moved is to measure the change of position. The dog changed position from this point to this point. This is the start point of the movement of the dog, and this is the point where the dog ended his movement. So in this case, if I want to measure the change in position, this would be 4 meters from north to the south. If I want, or if I'm going to measure the length between the start point and the end point with putting direction into consideration, then this is called displacement. If you notice that in the case of displacement, I have the numerical value, I have the right measuring unit, and it's the same as the distance, but plus the value or the numerical value and the right measuring unit, which is meter in this case, I have direction. So sometimes to simplify things, we can say that displacement is distance with direction, but it's not exactly distance with direction. It's the length between the start point and the end point. The distance is the whole path. I need to measure the whole path, but no consideration to the direction. Let's see another difference between the distance and the displacement. Let's say that there is this object that's moving from point -3 to point 4, and we need to calculate the distance and the displacement. Let's start with the distance. The distance is the length covered by the object, and the object covered the length between -3 and 4. How many units? 1, 2, 3, 4, 5, 6, 7 units. So the distance equals 7. 7 units, 7 meters or 7 kilometers, it depends. Now let's go to the displacement. The displacement is the length between the start point and the end point. This is the start point, -3, and this is the end point, 4. And again, the length between them equals 7 units. But what about the direction? If I am moving to the right, then the direction here is being represented by a plus sign. So it's +7. This is one way to get the displacement. There is another way, is by applying this rule. Displacement equals delta x, and the letter x here is not constant, or it's not a must to use it. It could be delta y, it could be delta z, it depends. Delta x equals xf. F here refers to the final point, 4, minus xi, and I here refers to the initial point, which is -3. The final point is 4, minus the initial point is -3, يبقى 4 minus -3 equals +7. What do we learn from this example? We learned that if we have an object and this object is moving to the right and doesn't change its direction, then distance equals displacement. In the value, 7 and 7, and in the sign or the direction, positive and positive. Now let's take another example. Again, we have the number line, and we have this object, and the object is moving from point 3 to point -1, and we need to calculate the distance and displacement. First, for distance. We know that distance is the total length of the path covered by the object, and the object is covering this length or this path. So this 1 unit, 2, 3, 4, the distance equals 4 units. Again, it could be 4 meters or 4 kilometers. Now let's see the displacement. Again, the displacement is the change in position between the start point and the final point or the end point. So we have this simple rule. Displacement is delta x, and delta x equals xf, which is final, the final point, minus xi, I for initial, the start point. Let's see this. We need xf, or the final point. The final point here is -1, minus the start point, which is 3. This means -1, -3 equals -4. What do we learn from this now? For the distance, we remember that distance is scalar physical quantity, and because it's scalar physical quantity, it's direction ignorant. Direction doesn't matter here, and the value is always positive since the direction it doesn't matter. But for the displacement is vector physical quantity. It's direction aware. The direction here is very important, and because the direction is very important, the value could be positive or negative according to the direction of the movement of the object. Another example. Let's say that we have an object that starts to move from point -3 to point 5. Then this object returns back from point 5 to point 0. We need to calculate the distance and the displacement. Let's start with the distance. The distance is the total length covered by the object. The object here covered 8 units. 1, 2, 3, 4, 5, 6, 7, 8 units. Then on its returning back, the object covered another 5 units. So the distance here equals 8 plus 5 equals 13 units, meters or kilometers. Now let's say how we can calculate the displacement. This is the start point where the object starts to move or started to move, and this is the end point. Okay, the displacement delta x equals xf, which is the final point, negative xi, which is the initial point. The final point equals 0 minus the end point, the initial point equals negative 3. So the displacement here equals positive 3. We can see that the object moved 8 units to the right. This is why I put the plus sign here. And then 5 units to the left, and this is why I put the negative sign here. The difference between them equals positive 3. Another two physical quantities, speed and velocity. One of them is scalar physical quantity and the other is vector. Let's see speed. Speed equals distance over time, and distance is a scalar physical quantity. Time is also a scalar physical quantity. No direction here is needed. But if we took a look at the velocity equals displacement over time, and displacement is a vector physical quantity, which direction is needed. So velocity is also a vector physical quantity. Let's see this example about speed and velocity and how to calculate each of them. We have an object. This object traveled from point A to point B and covered 30 meters in 30 seconds. Then this object changed direction and moved from B to C and covered 60 meters in 20 seconds. Then from C to D covered 30 meters in 10 seconds. The first thing we need to do is to calculate distance. Distance means the total path covered by the object. So the object covered 30 meters plus 60 meters plus 30 meters, then the object covered 120 meters. Distance is scalar physical quantity, no need for direction. Then we need to calculate displacement. Displacement is the change in position or the length between the start point and the end point. Since this is a rectangle, then the length of BC equals the length of AD. This means that 60 meters. Where is the direction? Displacement is a vector physical quantity. I'm moving from A to D. I'm moving east. Then displacement equals 60 meters east. Now we need to calculate average speed. Average speed equals total distance over total time. Total distance, 30 plus 60 plus 30, 120. And total time, 30 plus 20 plus 10 is 60. This means that 120 divided by 60, the average speed equals 2 meters per second. Now let's calculate the average velocity. Average velocity equals displacement over total time. Displacement, the length between the start point and the end point, equals 60 meters divided by the total time, 30 seconds plus 20 seconds plus 10 seconds, 60. So it's 60 divided by 60. The velocity equals 1 meter per second to the east. That's it for this video. See you soon.